Hello everyone, welcome back to the new video. I hope all of you are doing really good. Okay, so today we'll be talking about this paper which is titled as MemPrompt, Memory Assisted Prompt Editing with User Feedback. This came out early this year and it's from researchers from CMU and Allen Institute of Artificial Intelligence. So the central idea of the paper essentially says that retraining any large language model is difficult, it's time consuming, it's resource intensive, and that's often the case if you're talking about really large language models like GPT-3. So doing that process very frequently is doesn't make sense and also is not that possible. So they come up with a technique of creating a memory based on the user feedback that he wants to give to the large language model. In this case, we are talking about GPT-3 on the fly without getting into the trouble of retraining it again. So let's try to understand this through the example. So they have this table that says if user asked for, let's say, what word is similar to good, and GPT said the homophone of good is wood, which could be correct, but user then clarifies, right, that similar to means with similar meaning, because ideally what GPT returned is a homophone, which means the pronunciation of the word wood is similar to good. So that was the aspect of similarity that GPT captured. But user then clarified, no, when I say similar to, it means I mean words with similar meaning. So then GPT-3 says noted and writes that to a memory. So again, it's a temporary memory that is running outside a GPT model, not something that's updating its parameters. We'll look into what that architecture looks like in a moment. After that, if the user again asks the same question, he says what word is similar to surprised. And now since GPT had that feedback of understanding what a similar would mean when a particular user, let's say U1, asks about it, he knows I have to follow that feedback and replies with saying the synonym of surprised is amazed. So clearly, right, if you can see for a particular use based on the feedback that it's given to the GPT model in a particular session, or it could be out of session as well if you persist memory for longer. The large language model eventually tends to personalize as per the user's feedback. So it's kind of, if you think intuitively, it's you kind of telling GPT, no, I want it this way, or you're understanding that incorrectly. Please refrain from saying all of these things, or always reply with something that ends with this special marker. So all those are things you're trying to say GPT to follow just for you, because these are specific stuff that you want, right? You cannot go ahead and update the GPT model and infuse that knowledge in its parameters. So with this paper, you can do it. You can maintain a memory that is outside the GPT-3 infrastructure. But by creating an entire system around that and thinking of a logic to how to retrieve, how to save feedback, it is possible to steer GPT to adjust to your style of talking. Cool. So with this, you must have gotten some idea. Let's read through the paper and see how that architecture exactly looks like. So they have also written like they pair GPT-3 with growing memory of record cases where the model misunderstood the user intents along with the user feedback for clarification. Such memory allows our system to produce enhanced prompts for any new query based on the user feedback for error correction in similar cases in the past. So to understand this clearly, let's now directly delve into the architecture of what they propose. So this is an initial system that you currently run through. You are the user, you ask a certain query that directly goes to the GPT-3 model and it gives you a certain output. But again, there is no scope of GPT-3 again knowing based on your feedback if you want to tweak or make this model respond in a certain way. So now we have memory enhanced GPT-3. Okay, one thing also to note, this technique, what we are going to see, is agnostic of this model. You can plug in Llama 2, Mistral, GPT-4, or any closed or large language model for that matter. Because as I said, right, you are building an entire system which is outside of how this model is returning you the output. Cool. So now when you ask a query, instead of it directly going to GPT-3, what was happening in the previous case, it goes to a memory called M, which is nothing but a key value pair where the key is any question that the user asked at any time before this, let's say t minus 1, t minus 2, or let's say t minus k. And the value for this is, in case GPT was not able to give a satisfactory output at that point, then what feedback did the user give for this question to tune it to the correct feedback? So let's say for QT1, if the question was what we saw, right, which is what is the word that is similar to good, and the feedback that you gave was similar to means with similar meaning. And now if the new question comes in, what is similar to the word surprised, this X query goes to this dictionary, looks up for have we seen similar question before in the past. There is a matching algorithm that says yes, QT1 is an instance of that. We then retrieve the feedback that we gave for that question. We insert it or infuse it to the current question that we're trying to ask, which is what is the word that's similar to surprise? And we pass both of these things, which is the question and the feedback, against the question that is similar to what you're currently asking, which we have retrieved from our memory, and give that to the model. So now the model returns two things. One is the output, which is, let's say, XYZ, whatever it says. One is the actual output. So it might say, let's say, amazed. And the second one is its understanding of the input prompt or the question that you have asked for. So the intent understanding is what it returns. So why is the understanding required? So it's good to know how the model is thinking. Based on that, user can then derive if this was also not the correct answer. Based on that, user can go ahead and give it in the feedback that updates memory M with a new record. And again, that cycle continues. You ask a question, you check into the memory, you get the feedback, append it with the input, ask GPT-3 and get the output and the understanding of the intent of the question. So that's the entire crux of the paper. But now you might be thinking like, what if the user doesn't know the correct answer for? So how is he going to give the feedback? So again, this paper clearly states like you don't need to know everything for make this happen. Otherwise, there are only a handful of people that can go and use the system, right? So that's why the idea of you comes into play, where in the model tells you the understanding of what it understands or knows of what you're trying to ask and how it derived that answer. So by reading through that, you can make out if that is what you were expecting as an answer or is there something else. So that's the statement that we're talking about in terms of you delivering as a feedback. It's not something saying, okay, what's the capital of India? And the model says, let's say Mumbai. And you're not aware and you don't know it's Delhi. So that's why if it gives you stating why it thinks it's Mumbai, then probably you can justify and say, okay, this is not what I meant. These are a few attributes that a capital city should have. Now tell me what is the capital of India. And then most likely the model is expected to deliver the answer as Delhi. So that kind of things is what we are expecting the user to give input as a feedback. Cool. So let's move forward. Okay, so what they write is that we use the principle that if two inputs xi and xj, which are again two questions that user ask at different timestamps, if those are similar, then their feedback, what user would give, considering that the model is fixed, the model would respond to xi as, let's say, as yi, and for xj it would respond as yj, where yj should almost be equal to yi. This should be happening because xi and xj are more or less similar and the model is fixed. Then the feedback that you give for I should be applicable for the feedback that you could have given for the jth instance. So that's what is written in this highlighted paragraph. Feel free to pause the video and read through it. Cool. So their system essentially has the following components. So the first is memory, which again is a growing table of key value pairs where you have xi's as the query that the user asks and its corresponding fb as the feedback that the user gives in case he's not satisfied with the yi and ui that the model delivers against this xi. So this table of yours supports typical operations like read, write, lookup, and all of that. So then you have lookup as a component, which is nothing but function of the memory, wherein it takes in x in your memory and returns a relevant FBI for that matter. Again, they have talked about various methods to how they come up with this. So one is a simple method, right? You just do exact match of the query in your database and see if there is a relevant feedback or not. That's one of the methods. The second method is you embed your current query using, let's say, sentence transformer, get an embedding representation. And for all the keys that you have in your M, right, you maintain a vector representation of all of them in your some vector database. And then you do a cosine similarity between each of them. And whichever is closest and is above a certain threshold, that's probably a historical query that is similar to your current query. And you can then go ahead and reuse the earlier feedback for this query as well. But again, this poses a few challenges. They have mentioned that in paper. Let me just find it out 1 second. Yeah. So they say simple transformer are insufficient for tasks that involves more complex retrieval, which is when two lexically dissimilar situations can share the same understanding. So for example, if you're saying filing a false timesheet at work is one of the queries, and the second query is being at party and telling parents that I'm studying. So clearly exact lookup won't work. If you do sentence transform based cosine similarity, that also wouldn't work. But the underlying idea what you see is like it's all about lying to the authority. So the intent is similar, just that the context, the situation, all of that is different. So to deal with these complex retrieval and matching problem, the retrieval essentially has two components. One is the transformation, then you have retrieval. Now transformation is nothing but, for this they have trained a sequence to sequence model that takes in all these strings as input and outputs intent, which is a couple of words long. For in these two cases, it would be lying to authority. So they train their model against this. And during retrieval, it's all about then doing a cosine similarity based on sentence transformer along with as is match in the database keys. So with these two, they try to come up with normalizing a query to some common vocabulary and then using similarity based matching to come up with the closest ones. Now this semantic similarity again can be a hybrid one where you check in for the lexical variations along with the semantic ones. So that's again open to experiments, I guess. Cool. So let's go back to the components. Yeah. And then they finally have a function called combiner. What it takes is the original query queue and the feedback that we have retrieved against this query queue from our memory M. Now this is a gating function that allows for removing irrelevant feedback that we have retrieved. So I believe this can be as simple as putting a threshold on the final similarity that you do for your xi's and the elements of M. And again, as discussed, once you get the feedback, you essentially concatenate that with your current prompt or question and then pass it to GPT-3 for getting the answer. So this would look something like, yeah, I think this is an example that we can use. Okay, so what is akin to quick? So akin means something similar, and this goes to your memory. This is your M that you have come up with over time. And this matches saying, okay, what is a word like great? This looks something similar to this. You had a feedback because this was asked initially and the model gave something wrong. So the feedback given by the user was wrong. I want something similar. So this gets retrieved. Now the query that goes into your GPT-3 model is your Q, which is what is akin to quick, concatenated by clarification keyword, colon, wrong, I want something similar. And then this goes to your model and it outputs maybe let's say fast or something. So yeah, that's the idea how you can build it for yourself. Okay, so to talk about the implementation of combiner. So combiner concatenates your X, which is query with the relevant feedback FB that was retrieved from your memory M against the query X. All of this is appended. So the current implementation uses a threshold. Yeah. So they also use threshold based similarity between X and the closest feedback that you retrieve from your MX. Cool. So that's again something similar that I have explained. So it's important to understand that they say somewhere that their approach is not foolproof. The model may give out wrong understanding but a correct answer. So if that's the case, that's probably a situation where the model is hallucinating, which again is a current limitation of generative models, because it might have a certain understanding based on which it's kind of deriving the answer, which may not be aligned to how you are thinking. So those are the points that are still to be considered. And also one interesting thing, if you think about, right, it can go about injecting false knowledge over time and destroy the system, right? So as of now, I can just see a threshold based similarity just to say if the feedback was relevant to use it or to not use it. But some complicated gating mechanism is required to make sure that the system is not eventually turned down because of malicious users. So So some check has to be put at an input level, as in when the user gives you feedback FB, you should be able to say, okay, should I be using it or not? Does it correlate to the question that he has asked for? So based on that, you can take a call in terms of if that is a relevant feedback or not. But again, this is a check that we can put in. I'm not sure how to mitigate that situation, but yeah, it looks like something has to be done. So let me know in the comments if you are still listening at this point and can think of a certain way that can mitigate the situation. So I think that's pretty much for this video. I hope you learned something new and you enjoyed watching this walkthrough. If that's the case, make sure to hit that like button, share it across with your friends to whosoever is interested in such content. I'll take your leave now. Bye bye and take care.